dataset selection for transfer learning in information retrieval.
Thank you for that introduction, Hakuna. Hi, everyone. My name is Yastil, and I'm actually not going to introduce myself right now, since I've pre-recorded my presentation and I've done so in there. Please do let me know if there are any issues related to the audio or the video itself. But with that said, I'm going to now try to share the video. Is it clear? Can it be seen?
Yes, it is.
Cool. Okay, I shall start it now.
Good afternoon, colleagues. My name is Yastil, and I am from the Department of Computer Science at the University of KwaZulu-Natal. Today, I will be presenting a paper entitled Dataset Selection for Transfer Learning in Information Retrieval, which has been accepted into the Springer Journal. Before I start, I have two supervisors who must be recognized. These are Anban Pule and Edgar Jambere. To begin with, it is important to understand what information retrieval is. Well, in essence, web search engines like Google perform information retrieval. As a user, you submit your question, which is technically known as a query, and in less than a second, you will receive a list of relevant results. Simple enough, but for the purpose of this work, we need to take a closer look at how these search engines actually work. Quick disclaimer though, I do not actually know how these search engines work, since it is proprietary knowledge. However, the research community have made some assumptions about their functionality. Specifically, they broke down the retrieval process into two distinct stages. The first stage utilizes a non-neural system to retrieve the top 1,000 or so documents from a very large collection. A neural system then ranks these documents in descending order of relevance. Our work focuses on the neural system, since they have only recently been introduced to the field of retrieval. Now, the term neural networks can be considered as a generalization, especially in NLP, since these days they can be broadly classified into two categories, namely randomly initialized and pre-trained networks. In this work, we focus on the pre-trained BERT architecture, which was released by Google in 2018. Although neural networks in general have advanced the state of the art in retrieval, their performance when provided with limited training data has been severely criticized. In fact, recent studies have shown that non-neural systems outperform neural systems by a large margin when training data is insufficient or non-existent. Consequently, researchers must create vast amounts of training data for every new search domain. For this, they rely on either manual or automatic methods. Of course, due to human involvement, manual methods are time-consuming and expensive, but they do produce very high-quality training data. Conversely, automatic methods are fast and inexpensive, but ultimately produce low-quality training data. To this end, we propose a new method to source training data, which puts a green tick next to every desirable characteristic. In essence, we argue that there is no need to create training data for every new search domain. Instead, we propose that one can simply reuse existing human-labeled training sets from other search domains. Now, in deep learning, this process is technically known as transfer learning. But there's an obvious problem with this approach. Which dataset do you choose? This is exactly the question that our experiments aim to answer. Specifically, we investigated 3 features and identified which one should be prioritized when selecting a training set. The first feature was vocabulary alignment. For example, if your domain consisted of scientific literature on the novel coronavirus, should you select a medical-related training set to minimize the vocabulary mismatch? The second feature was scale. In other words, should you select the largest available training set? And finally, the third feature was query type alignment. Put simply, should you select a training set whose query type aligns with your domain? To better understand query type alignment, let us consider an example. Imagine that you are designing a neural search engine for an e-commerce website. Should you select a training set that consists of keyword or natural language type queries? Well, in this environment, customers typically use keywords to search for products. Hence, to satisfy query type alignment, you would select a training set that consists of keyword type queries. In this case, it would be training set A. Now, it is worth emphasizing that queries can only be categorized as either keyword or natural language type. This really simplifies the dataset selection process. To determine which feature was most important, we used a right-tailed t-test. Let us consider the scale feature as an example. We fine-tuned 2 identical BERT models on different datasets. One dataset consisted of over 1 million unique training samples, while the other was many orders of magnitude smaller. We then evaluated the performance of each model on a benchmark dataset and compared their results using a right-tailed t-test. In essence, if the performance of BERT after training on the large dataset produce a statistically higher result than training on a small dataset, then we concluded that scale was definitely an important feature to consider. Based on our experiments, we have proven that neither scale nor vocabulary alignment represent important features to consider when selecting a training set. Instead, we have discovered that to achieve optimum performance, one should select a training set whose query type aligns with their domain. Using this information, we were able to achieve first place in round 1 of the Trek COVID challenge. Now, unlike traditional retrieval challenges, Trek COVID did not provide any training data. More importantly, due to time constraints, participants were unable to manually create training data. Consequently, many relied on automatic methods and unguided transfer learning to train their models. By achieving first place, we demonstrated that our guided approach to transfer learning is highly valuable in search applications without any domain-specific training data. With that said, I would like to now formally conclude my presentation. Thank you for your time, and I welcome any questions.